Hello viewers, welcome back to the channel. Today we're talking running electrical lines, and I've just finished running all of the Romex, more or less, for the house, and boy was it a task. First off, I doubled the amount of wire I thought I needed. So whatever you think you might need, you need more and you probably need double. Or you're just really good at estimating and I suck, which is probably the case. And with material prices increasing right now, because it is April of 2021, yeah, I paid double for the spool for the new Romex versus what I bought originally. So that was fun. So you look at the main panel. It's a square D home line, 40 space, biggest one I could get. And I'm just going to kind of take you through some of the circuits, what I've done, and kind of walk the house and kind of show you generally what I'm doing. First step, we talked about kind of EV chargers and electric vehicle chargers. I've got 3/4 inch EMT conduit stub out, so this will poke through the drywall, and then I'll use what's called an LB kind of pull box to transition to a 90 to go along the wall and then connect to those boxes that we showed earlier. The rest of the runs are coming in from the top. I tried to make it as neat as I could, using these what's called cable stackers. The red ones are garden bender, the white ones are 3M. This tells you how material shortages are working. I get what I get. I actually like the 3M ones better. I think the garden benders can hold more conductors. Like you can double up 12 twos in them. The 3Ms you can't, but the 3Ms work, I think, a lot better. So these are all of the circuits for the house, for the home runs. All the yellows are 12 gauge, 20 amps, and those are primarily receptacles. I've got a few dedicateds. I've got a dedicated microwave circuit that's also running the starter for the range and the vent hood. I've got a 20 amp run to the side of the house to run like a chicken coop and whatever kind of livestock stuff. I've got, well, I think that's about it for the 20 amps. All the white are 14 gauge, 15 amp, that's lighting, and then a 15 amp for the dedicated 15 amp for the fridge, kitchen fridge, and a dedicated 15 amp for the furnace. A couple specialty circuits that I ran, dedicated 20 amp for garage fridges and freezers. So I had that. I have a dedicated 20 amp for my network rack and for telecommunication equipment. Let's see here. I ran a 6.3 for the oven, which will handle up to 50 amps. The oven we got only pulls 40, but some can pull 50, so might as well run the heavier stuff, and then I'll just put a breaker on this at 40 to limit the current, and then I'll have the upsized conductors if I ever want to do something bigger in the future. Standard 10.3 Romex 30 amp for the electric dryer, and then I've got a 10.2. What's this one? Yeah, the other oranges are 10.2, 10 gauge, 30 amp. One of them is 120 volts for the septic system, the aerobic septic system, dedicated. And then I have a 8.2 and another 10.2, and those are for the master Whirlpool jet tub. The 8.2 is for the tub itself and the pump and the motors, and for the jets, and the 10.2 is for the supplemental heater. Now, you may be asking yourself, what kind of tub did you get that requires that much, that would pull that much current? Well, in truth, it doesn't, but because the tub and the panel are literally on the opposite sides of the house. So, per the manufacturer's instructions, this is why you read instructions, they recommended upsizing the conductors, 2 sizes if you're over 50 feet, I think. I can't remember the exact numbers, but we were over. So what was normally a 12 gauge 20 amp circuit is now an 8 gauge, and what was normally a 14 gauge 15 amp circuit is now a 10 gauge. So they'll still be breakered at 20 amps and 15 amps respectively, but we upsize the conductors to deal with the voltage drop, so we don't have an excessive voltage drop going that long of a distance. So let's just kind of pan around and see what I've done. in these rafters, we just let the conductors run wild. You don't bundle these things. That will generate heat. Heat is bad for electricity. It starts fires and stuff. So the more air movement, the better. So you actually let these run wild, even though it's a little messy. I mean, it's within code and plenty of airflow around them. And just kind of walking the house, you'll see how we actually run all this stuff. You basically run for a given circuit, and let's pick a simple one. Let's pick the garage fridge and freezer. I think that's a simple one. So what we did, well, now I gotta find it. Yeah, so we went out of the panel, up, along these rafters here, above the mechanical room. We made a turn, we went through here, and then we came down, 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 into our first outlet here. And I labeled everything. I can't stress, you want to label everything. And don't use abbreviations too much because you will forget. You will forget and then be scratching your head trying to figure out, what does this mean? And my buddy, who might be watching, knows exactly what I'm talking about. So I went verbose with my labeling. I learned my lessons from him. Thank you. So here we have garage fridge -HR, home run. That goes to the panel. And then I have going out from the outlet, garage fridge C. C for center. So garage fridge here to the center outlet. I've got garage fridge L, garage fridge R. So left, center, right. You make up your own naming convention. In this case, this is the last outlet, so there's only one wire coming out. That's basically how you wire a circuit. All the other circuits in the house are the same thing, just longer, bigger, etc. So here's my example. I ran all the garage outlets in the mechanical room and the garage outlets and mechanical room on one circuit for the outlets. The laundry has to be on its own dedicated circuit. All the outlets here, so like that outlet there, he goes up, right, and around and down to this outlet, right, and then to this outlet, right, and then down to here. So, what else did I do? I ran 3 receptacle circuits for the downstairs for all the outlets. And then I ran lighting circuits. I basically did a garage and outdoor and laundry. Then I did a downstairs for the rest of it. And then I did an upstairs. And that's not a lot of lighting, but LED lights are a thing now and they don't draw much power. So you really don't need it. I could probably get away with less circuits than that, but I just ran more for convenience. So let's quickly talk about lights. The simplest way to wire this, right, is you have power coming into a switch box from somewhere, right? And it follows the same kind of logic as the receptacles. You get power into the box, you take power out, okay? And then you'll have a switch in here, and then you have a lead going from your switch to your light. And like I said, labeling, right? So in this case, I've got power in from the guest wall switch. I have power going out to feed the bathroom. And then I've got what's called your switch leg going up to my light. And it goes up to my light. And I just have it hanging out, right there. So for this first step of rough-in, all these Romexes are just left long. Code says you need at least 6 inches coming out of the box. Do more. You'll have some waste. Accept it. And know that you will never have anything too short. Accept that you're going to have some waste. Don't try to skimp on this stuff. Wire, well, used to be cheap, but it's cheaper than having to redo the whole thing or having a lot of frustrations because your wires are too short. So that's how a simple switch works. Wiring fans, this is another common issue. With a fan, you run what's called 14-3. So in this case, it has an extra red conductor, white, black, red. And so that runs up to just your fan box. And so that way, you basically have 2 switches connected to this, and they share the neutral, the white. Typically black's for the light, red's for the fan, and yeah, that's how you run those. Another common scenario is what's called a three-way switch. And I am going to see if I can find an example. Here's an example. So a three-way switch, you'll have power coming into the box. Okay, so in this case, here we go. This is lower lights home run. So this power is coming in. Then so that's power coming in. Then we connect that incoming power to one side of our three-way switch, to the power inside. And then we connect this 14.3 again to the other side of our three-way switch. And then the black and the red are called travelers. Again, I'm not going to explain how all that works in detail. There are other YouTube videos way better than that for me to, that I could do. I'm just telling you that this exists. I'm telling you some terms, and I would recommend checking out the plethora of YouTubers that do electronics explaining, like Electrician U and some of the other guys. They do a fabulous job, way better than I could do. So for a three-way switch, you run this 14.3, and it goes all the way over. In this case, it's going to go over here to this switch box. Coming in from here, here's the other end of the cable. That will connect to another three-way switch. And then the power side of that three-way switch then goes to the lights. In this case, it will go to a normal 14.2 that would go, in this case, running the kitchen lights, which I haven't wired just yet. And so that, doing that, you have two switches that can control the same set of lights. So you flip one, the light will toggle either on, off to on to off. And then if you go to the other switch, it will toggle, and they ping pong back and forth. And most houses have this feature. So that is how that actually works. It's how it's wired. You can also have what's called a four-way switch. And basically what that does is you have two three-way switches. Well, if you put another type of switch in the middle, they call it a four-way. You just connect that 14.3 to one side of that switch. It's got an extra terminal. Connect another 14.3 to the other side. And then you can put as many of those as you want in your kind of loop. So you could have, n number of switches controlling the same light. In my case, I've got that for a lot of the living room lights. So I've got the living room lights. Where are we going? We start here, over here by the entry, right? We've got power coming in, right? And we've got our first leg that'll connect to our three-way switch, and that goes over to this switch box. That's from here. That'll connect to one side of our four-way switch. The other side of our four-way switch will go to this one. All right. And then that takes it all the way over here to the side of our three-way switch. And then our power out from the three-way switch goes up to the light. If you notice, I adopted the convention really of using directions. So in that case, living north. So that's the living room north box. And I know, because it's white, I know it's a switch box, not an outlet. We don't get those confused. All right, so north, northeast, master, west, fan, outdoor, right, laundry, west. So you can see, use verbose labels. It will help you in the long run. Guys, I think that's almost about it. Oh, let's talk about smoke detectors, because that goes along with all this too. That's the last thing we'll talk about in wiring. So basically what you do is you start with one smoke detector, get power to it, just with your 14.2 cable, and they can be on their dedicated circuit. They could be on a different, tapping off of another circuit. I chose to put mine on the lighting circuit just because breakers are expensive for these modern arc fault GFI breakers. And so the smokes don't need to be on their own dedicated circuit. They don't draw any power. So I just put it on the lower lighting circuit. So I've got, you see the thinner cable there, I've got power going in, and then the 14.3, again, using that as a fatter cable, those connect to all the other smoke detectors. And so if you ever looked at a wired smoke detector, they've got black for power, white for the neutral and the return, And then they use the red wire as a communication wire to each other, as an alarm wire. So that's how it works, where when one smoke detector goes off, they all go off. And that's how that's accomplished. So very important to get that right with the right wires. I guess the other thing I'll talk about just for budgeting your own project. So this house, right? My 2-story house, 5-bedroom. I think the square footage is going to be around 3,600. And for all of this wiring, I used for all of the outlets. Oh, I should also mention outdoor outlets. I tapped off the nearest outlet wherever I could find it on whatever circuit. I made it easy on myself so I would save some cable. So for all the 12.2 that I used approximately, I used over 2,500 feet of 12.2. For the 14.2, I've used about the same, almost 2,500. Actually probably a little more than 2,500 feet. 14.3, I bought a 1,000-foot spool of 14.3, and I'd probably have about 100 feet left, maybe a little more. And then for the other odds and ends, the dedicated circuits, I used, for all that 10.2, I used about 300 feet of 10.2, and then 100 or so for that 8.2 for that dedicated circuit. And some of that stuff I overbought on. Like I bought 125 feet of 6.3, and I could have got away with probably 100 or 110, but I didn't want to be short. And that stuff is expensive where you're just buying it for one run. It's not like you really want to have a spool of the extra stuff lying around because it's just too expensive to have. So, but maybe that'll give you an idea of kind of what to budget based on your size of your project. I definitely undershot mine, but that's all right. This is a learning opportunity. Oh, let's also talk about grounding. Because I know with an electrical video, it seems that you guys are really, really interested in grounding, especially if I don't mention it correctly. So let's talk grounding. So this panel is going to be a sub panel coming off the shop like we've talked about earlier. So it will have no bond screw. Notice we do not have a bond screw. I threw that thing in the spare parts bin as soon as I got this panel just to make sure it never got installed. So, and we have ground bars. All right, there on the other side. And then I went ahead, you see the green 4-gauge aluminum, I bonded those 2 bars together so we had something beyond just the metal case to actually bond the ground bars together, just because it's scrap wire, why not? So for grounding and bonding on this thing, for starters, I've got basically 3 wires for grounding. The first, and I would wager probably the most important, is the UFER. So we talked about the UFER, and this HVAC ducting in the way. See our rebar coming out of the wall there, right? So I've got just a clamp here, and yes, I'm touching wires. There's no power into this house at all. So just to let everybody know. And then we have a number 4 copper coming off of that. That's what's required for the UFER. Black wire, I taped it with green tape to denote a ground. I think that is required by code on number 4 and larger conductors to identify it if the jacket isn't color-coded. And that goes all the way back to the panel. So you can see it going all the way back to the panel. Okay, and we just hit the ground bar. And I chose to use a lug for this because it just made it easier than trying to fit this number 4 wire into there. The ground bar says it'll fit, and I think it will just fit, but you got to hit it perfect. And there's not a lot of space here, so these ground lugs are cheap and made it a lot easier. The next, where is that? The next one is right there. This number 4, again, number 4 copper, is for the gas bond. Now, I don't think I strictly need to do this, but it doesn't hurt. So this bond wire, and you can see here in the mechanical room what I did is I ran it in here, and then I tried to make it pretty. So I bent a little bit of EMT, got an escutcheon, all right, just running it into this conduit. I used a NM transition connector. I know it's THHN. I'm sure it's technically a problem, but I just don't care. It's the cleanest way I could see to transition it to protect the cable and everything. And so it is bonded to the gas pipe here with this big old connector. I think technically for the propane system and natural gas, if you're running black pipe like I am, you don't have to do this, because I think the appliances will basically bond and ground themselves through their own circuitry and the piping, and so that would be good enough. But I went ahead and did that just in case. It doesn't hurt, and so just to make sure I covered all my bases. The last piece of bonding that we ran was this number 6 bare, and this could also be a number 6, insulated. Bare was just cheaper. And this is for the inter-system bonding bridge bar. So, and that runs, again, just all the way back to the panel. And so what the inter-system bonding bridge bar is, let's see, it runs right into there, in the ground bar. That is for all your telecommunication equipment, low voltage equipment. So your DirecTV satellite dish, all your internet providers, they have to bond all their equipment. And this number 6 wire will be hooked to a little box on the outside of the house that all those companies can land all of their bonding wires to without having to crack open the panel. So it's a way to integrate into the grounding and bonding system of the house without having to open up the electrical panel and have an electrician do it. So it's just a safety thing. So that'll be ran over there with the other telecommunication equipment. And okay, so I think that's it now. Things that I have not done. I have mostly stapled everything. I still haven't gone through with like nail plates and that kind of stuff to protect all the wires. If you drill too close to the edge of a stud, you have to put a nail plate in to protect it so the drywallers don't run a screw through your wires and make everyone have a bad day. I'm trying to see if I can find a good example. See, like right here, I think that hole is a little too close. I think you have to have 1 1/4 inch. If you're on a 3/4 inch hole, I think you've got like a 1/4 inch plate on either side. So in this case, I think we are just too close to where I'd probably have to put a plate on that. So at least for my project, I'm not getting out there with a tape measure or anything. If it looks close, I'm just going to nail a plate and move on. Okay, I think that's it now. This has been a long video. I've been talking a lot. So thanks again for watching, and we'll see you in the next video.